Welcome to the second video in the series about Elasticsearch's e-commerce accelerator called PRISM. PRISM stands for Policy Rules and Intent Synthesis Middleware. In this video, you'll learn how PRISM leverages percolator queries for finding relevant policies that ensure that results match user intent, as well as the difference between hard filters and soft boosts. Additionally, you will see some of the debuggability and traceability features of PRISM. So first, I want to motivate why interpretation is required. And the difference between matching text and matching intent. So if we look at a user searching for oranges and we are just literally matching the word oranges, the text oranges, we can end up with products that are not only oranges, the fruit, which is probably what they're looking for, but also products that have the word oranges in their name, such as orange marmalade or orange soda or orange juice. If we have interpretation enabled, and I'm just going to flick this switch to turn it on, we can show the user only oranges. So now what we're doing is effectively restricting the results to only show products that have been tagged as being in the category of oranges. And you can think of it, if you were in the real world and you walked into a grocery store and you asked for oranges, they would probably direct you into the fruit section because that's where the oranges that you're looking for would be. They probably wouldn't send you into the orange soda section or the orange marmalade section. So it's a matter of understanding the intent and redirecting the query. So to do this, here's what the PRISM architecture looks like. A user search comes into a retailer's application server, and without PRISM, it would just go straight through and be executed against a product catalog. And that's when you get just text matches. But with PRISM, the user query is redirected into the PRISM engine. And this is the part that we're going to focus on today a little bit. The PRISM engine does a percolator lookup against a policy index. So for example, if the user had typed in the word oranges, that would be a match for a rule that says restrict results to the category called oranges. And effectively, it's redirecting the user or a visitor to a store into the fruit section. In this case, we have even more specific tags, and one of them is actually a tag for a category called oranges. PRISM will then receive that policy, and there may be multiple matches. It will receive them and combine them and send them back to the application server, and the application server will execute a query containing the category filters and other information received from PRISM, and will return relevant results. So what does this look like? Well, in PRISM, we have a policy called, well, you give it whatever name you want. In this case, we've called oranges fruit. And what it's doing is we're saying if the user has searched for a string which contains the word oranges anywhere in the query that they've typed in, then what we will do is we will create a new query to execute against the product catalog. And in that new query, we're going to restrict the results to only the products that have the category field with a value of oranges. So effectively, we're restricting the results to only the results that match this category, which is oranges. We also have here a hard filter, which means only show products where the category is tagged as being oranges. So if we execute that query, there's only 32 hits. You can see up here in the top right corner, but all of them are oranges. Oranges, they're all tagged as being in the oranges category within this e-commerce catalog. So how does this work? Well, it leverages a percolator query, but to show the difference between a percolator and a standard query, I'm going to first talk about a standard query. So if a standard query were executed against a product catalog, it would look like this. You have products on this second row here: orange fruit spread, orange juice, juicy oranges, olive oil, chocolate, etc. And the query is compared against each of those products. So if somebody's searching for oranges, you would say, does it match orange fruit spread? Well, yes, it is, because typically when searches are executed, they're actually stemmed. So oranges would actually become a search for orange, and that would match orange fruit spread. It would also match orange juice. It would also match juicy oranges. It would not be a match for olive oil. It would not be a match for chocolate. But if you look at the intent of what the user has looked for, oranges, well, orange fruit spread might not be a good intent match. It's a good text match, but it's not a good intent match necessarily. Same thing, oranges, if they're looking for oranges, they might not be looking for orange juice. So how do we handle that? Well, as I just mentioned, we actually perform a two-stage lookup sequence. So the first stage is actually looking up a rule that says, hey, do we have any rules that need to be applied against this user query? And so that actually flips the order of how search works. Now what we're doing is we're actually storing queries inside Elasticsearch. So the query would be, did the user search for oranges? Did the user search for olive oil? Did the user search for cheap? Did the user search for without? And so those queries are then compared against the text that the user has entered. Did the user enter oranges? Well, the text is oranges. So yes, that's a match. Let's fire that rule. Did the user enter search for olive oil? Well, they entered oranges. So no, that's not a match. Did the user search for cheap? No, they entered orange. It's not a match, and so on. So that's how a percolator query matches policies. So if we go back to the results, you can see that there's 32 hits. But what has happened? Well, if you click on the developer tools, this little debug symbol in the top right corner of the page right here, and if that's turned on, we can see the first query is a percolator lookup. It's against the policies index. And if I copy that and paste it into DevTools, we can actually execute that. And the result is a single hit. So that a policy for oranges that we were just looking at in the UI is exactly this one here. The interesting part of it is this percolator section. So this is the component of that policy that is actually being compared. So it's a match phrase against the text that the user has entered in. So we're checking, did the user text contain the word oranges? And in this case, it did. So that's why this is a hit. We can also see there's other information here in the developer tools. I'll cover in more detail in the future. And then you can also see the execution sequence. In this case, because there were 32 hits for a strict match, so we had a good set of results. This is the only section or the only query that was executed. But we also can do fallback to spelling correction, relaxed queries, and even semantic queries if we don't get enough results. But for now, I'm just going to copy that and paste it into DevTools. And if we execute that, we get 32 hits. So again, now this is a query against a product catalog where we're actually, this is the rewritten query. If you look at it, we're matching the word oranges against a field called full text. We're matching the query oranges against a field called title. But also, and this is what the rewriter or the PRISM Engine just did, is it added in a filter and it says only return products where the category is in the or has a value of oranges. So then if we look at how, actually I wanted to show what happens if we were to change that to a soft boost instead of a hard filter. So if we do that, that means that now we're not restricting the results. We're just boosting up the results where the category has a value of oranges, but also show other relevant products. So if we go back and do that search again, we can see that there are now 3,283. The first hits on this page are mostly oranges, or maybe they all are even, but we're providing a lot larger recall set. You can see how the score is being impacted or calculated here. We can see that the policy oranges has been triggered and it's added a weight of 0.7 to the score multiplier. So effectively you have a base score, which is BM25. We have 1 plus something, and in this case is 0.7. That's defined in the policy that we were just looking at. And we also have it multiplied by margin boost and popularity boost, which we will not go into detail in this presentation. Again, if you were to look, where did that soft boost of 0.7 come from? It's down here. There's a weight of 0.7. So all of this multiplicative boosting is discussed in detail in this article, Influencing BM25 Ranking with Multiplicative Boosting in Elasticsearch. And this approach is used for the popularity boosting, margin boosting, user history boosting, cohort boosting, and as well as the policy boosting that we just looked at. So thank you for watching.